To be part of Professor Duran's team here in IDC, and also to be a PhD student of Fabien Lotte and Jérémy Matou, those two who presented earlier. I will talk about I'll talk about the taxonomy for adaptive BCI, the user and task modeling. It's more, I will be addressing more the general public, so for the BCI novices. So I hope it won't be boring for the ones who are also experts. Nobody, okay, I should move it. Okay. So nobody really mentioned the four major steps of BCI. So basically we are acquiring the signal, the activity. We're measuring the brain activity. In my case, we're measuring electrical brain activity with an EEG. And then we try to filter some specific frequencies, because it depends on the task of a BCI, specific tasks, and we try to extract features, important features that make sense, and then translate them into simple commands. For example, for motor imagery is left or right, if it's imagining left or right hand movement, and then these commands are presented as a feedback, in this case, this little ball which goes left or right. So the goal of my talk will be just to, well, a simple goal, I hope, is to convince you that the feedback is very important, although it's often being neglected in our community, and also that in order to improve the BCI performance, we need to think about adapting the system, making it adaptable and adaptive. We often overlook the difficulty to manipulate the machine with only one's brain activity, because the person needs to focus all the time, and there are so many factors that influence the performance and of such manipulation, the success of such manipulation, which can be mood, attention, muscle tension. For example, for motor imagery, the simple strategy of imagining visual or kinesthetic movement, imagination of the movement, or and so on. So if the person during the experiment, if they don't know how to manipulate the machine, or they don't understand how to do it, then no machine learning or signal processing method can compensate. I'm paraphrasing Fabien. So why spend so much time in developing the machine learning strategy, while we can actually try to help the users stay more focused and influence the signals through the feedback, the environment of the BCI, so within a BCI task, or simply through the machine output. So it needs to be as clear and as engaging as possible to keep the users away, to keep them from drifting away. So I want to give you an example of a study for how important the feedback can be. It's so the participants had to draw triangles or ellipses on a pad, and they didn't know the correct form, size, or position of these forms, objects, and so as guidance they used the typical BCI feedback and instructions that is used for motor imagery that you already saw in previous presentations. So which is basically the blue bar that augments if you are close to the correct answer, and the blue bar diminishes if you are far away from the correct answer or completely incorrect. So this seems like a simple task, right? We're just drawing triangles and circles. However, out of 54 subjects, 17% of them were not successful, which means that they couldn't find the correct form or position at all during the whole session. And none of them were, I think, if I recall, none of them were 100% successful. So what does this say about the feedback? Well, it says that it's not enough explanatory. It doesn't guide the users enough to understand how to create, how to perform the task. And you can understand that in BCI, then when the task is even more difficult, the success rate is even smaller. So there have been many attempts to create more collaborative, playful, immersive environments, BCI environments, and they have indeed shown that the performance has increased. And also to give you an example for a P300 speller, where instead of using the simple flashing, they would use they would flash different groups of letters, so not columns or rows, and they would present smiley faces because humans react to faces. And again, the performance was much more increased. Okay. I hope I convinced you that the feedback is important. So my second point is to talk about adaptive BCIs. So in the beginning, depending on the BCI task, we filter certain frequencies, extract features, and we expect certain brain regions to be activated. But should we expect that to be the same from the beginning till the end of the experiment? Well, we shouldn't, because the experiment lasts at least for 1 hour, and the person changes their mood, their attention, they become demotivated, tired, or whatever. And all of these new features, they diverge from the initial ones, and also the brain regions that are activated also change. So the performance gets even worse at the end of the experiment, because the classifier would expect the initial features to classify something that has been trained from the beginning, the features from the beginning, and it completely changed by the end of the experiment. So that there have been works to adapt the system, which is, for example, to filter different power bands, to adapt the power bands and take into account different spatial filters, and also then dynamically update the classifier during one experiment. The same, so that was for motor imagery, and also the same, there are many, many works on, for example, also ERPs. However, they are trying to adjust to the signal variability. They are actually fixing the effect without really considering the cause. They could influence the cause through the machine output to reduce the negative variability, the negative behavior. So instead of just dwelling with and fixing the signal variability within the machine, within the signal processing, they can influence the user to create a desired behavior. Okay? So we propose a taxonomy or a general framework for adaptive BCIs, in which we encompass and give the opportunity, or maybe more like take into account that we can adapt the task and we can optimally influence the user, and also take into account the user model, and through both of these also they project, they reflect within the physiology of the user. So let me explain the model, the framework. So the user model is arranged by the changeability or stability in time, which means that for example, attention drops or mood swings would operate in short time periods, while skills or some cognitive abilities would take a longer time to develop or deteriorate. And for example, some physiological predispositions that are bound by gender or age, they also can change. They're not necessarily bound. That's what I want to say. Because, for example, an elderly who trains can have better physiology than a youngster that doesn't that neglects himself, for example. So someone who trains can, so this is all changeable, that's what I want to say, and in different periods of time. And with this change, we can achieve a desired state with an optimal task. So we propose that, in this case in BCIs, that the purpose of a BCI can be, for example, controlling a wheelchair, communicating, or rehabilitation, etc. And each of these goals can be achieved through different paradigms. So motor imagery, as we said, P300 or SSVP, different paradigms in BCI. But if the person is not able to create motor imagery for controlling a wheelchair, for example, then the BCI should provide the possibility to switch from one paradigm to another to enable the user to use this system. Even though one paradigm doesn't work, the other one would. And also, for example, the same goes for the exercise, which means that if someone is imagining hand movement in the motor imagery paradigm for control, if they're not so performant with imagining hands, maybe we can switch to imagining foot movement or tongue or other proposed exercises that exist. So, and at the same time, depending on these two, we can, for example, we can imagine the temporal filter would be for motor imagery from 8 to 30 hertz. So we know prior to task, or if it's prior to task, we know which filters we will use and how we would adapt them. Okay. Sorry, it's not moving. Okay. I skipped one. Okay, and these all would work together with, thanks to an intelligent agent that we call a conductor, and that would choose when, how, and which element it would update and change during different periods of time. Okay, so when, with time. It will work, this conductor will work based on an objective function, based on some optimization criteria. For example, I will mention something that's called flow. So we would want to, for example, optimize user state, user subjective state. And here it's the state of flow, and the state of flow is a state full immersion and full, the person is completely forgets about the time, they forget about themselves or the environment, and they are fully immersed in the task. So we want, for example, them to feel in this flow. We want them to have a pleasurable experience with the BCI. So I will give an example for a motor imagery. We designed a video game called Tux Racer. Actually, we modified an existing video game for the motor imagery. And for example, on the other hand, if the objective function would be to optimize the speed or the accuracy of the machine, in this case, P300 speller, then the adaptation would completely change. So you see, the conductor would choose which elements to adapt according to what's this optimization criteria. So this is an example. I'm sorry, but my computer. 1 minute. Oh, I wanted to show you a movie of this. So we had the task was to have a penguin to catch fish on the left or on the right, and the person would imagine left or right hand movement. And so indeed, we tried to adapt the task online. And so the point was to help the users be in flow, and then consequently have have better performance, which did happen. So and in the second study, where we wanted to optimize speed and accuracy in the P300 speller, we added to an existing method that's called optimal stopping, we added something that's called optimal flashing. So we actually try to act on the user. We try to act on them so that to get desirable behavior and less signal variability. So we got really good results from 18 subjects. So my point was, feedback is very important. We need to adapt the BCI. For that, we need a taxonomy. We can act on the user instead of only adjusting to signal variability, and also to orchestrate all of this adaptation, we need an intelligent agent that has optimization criteria behind. Thank you. Sorry.
Any questions?
Yes. Anybody ever attempted to quantify the level of alertness or tiredness in a mathematical
Yes.
way?
Yes.
Not just, oh, I want to make him more alert or...
No, of course. There have been, in the literature, they have been trying to quantify it, and they have with different methods, for example, using passive BCI, EEG, so they through different physiology and with different mathematical calculations, they would calculate the alertness, fatigue. So there are many works about that, but they haven't implemented these methods in a BCI. So in what I mean is, because BCI is always used simply, usually without any adaptation, without taking into account this alertness. But there are works separately that quantify this. So I'm just saying, let's implement all these methods in BCI to improve it and to adapt it according to the user changes. Is that okay? Because I have notes, I can give you all the literature, the works that are doing quantifying in the break if you want.
Okay, Jelena, thank you very much.